Hello everyone, Mr. Taylor back with you as we get ready to rumble through two-step equations. Prior to this video, we looked at the first beginning of working with two-step equation as it included addition, subtraction, and multiplication. Here, and just like the last one, we're not going to worry about the algebraic tiles and the diagram. We're going to use that space to do some mathematical rules as such. Okay, let's take a look at problem 4. Problem 4 tells us that x divided by 2 plus 1 is equal to a negative 2. So x is being divided by 2, but it's also 1 is being added to it. So as we rewrite, so we have x over 2 is equal to, no it does not, so I didn't like that x anyway, so we'll just start over and let's pick something different as far as the color this time. So we have x divided by 2 plus 1 is equal to a negative 2. Well, since we see that there's a plus 1, or should I say adding 1 to both sides, in order to clear this, undo it, we must subtract. So we're going to subtract 1 from both sides. That's going to give us here, we'll bring down our x divided by 2 because 1 minus 1 is 0. But over here, we have a rule that's involved. We have negative 2 minus 1. Remember those integer rules. Say we do same, opposite, opposite. So we're left with negative 2 plus a negative 1. The rules of addition say you just add them up and keep the sign. So we'll wind up with a negative 3. Okay, that makes sense to you. Now, as you can see, and I'm going to take my little arrow out of the way here because it's in my way. As you can see, we literally have x, and x is being divided by 2, so the inverse means let's multiply. So we're going to multiply both sides by 2, and that's going to be is equal to a negative 3, and that's times 2. Now what's happening here, we can do 2x if you like, make that 2 over 1, and we have times x over 2, and we can make that 2x over 2, which is the same thing as 1x. But what I'm going to do is I'm going to cross divide, and 2 goes into 2 1, and 2 goes into 2 1, and that's going to leave me 1x is equal to, and then 3 times 2 is 6, but a negative times a positive gives me a negative 6, and of course that's just telling me that x is equal to a negative 6. So now all I need to do is check to make sure that what we did was correct, and hopefully we don't have another situation. So let's see. We have, again, x is a negative 6. So let's say if we take a negative 6 for x divided by 2 and then add 1. So we don't know, we're going to hope that it equals to a negative 2. Here I have 2 divides into 6 3 times, positive into a negative, negative plus 1, looks good guys, is equal to a negative 2. And of course, again, here's this rule of integers, and this rule says the absolute value of negative 3 is equal to 3, and the absolute value of 1 is equal to 1, and we're going to subtract 1 from 3, and we're going to get 2, but because the absolute value of negative 3 was larger, we'll wind up with a negative 2. So a negative 2 indeed equals to a negative 2, and we have an identity. All right, let's see, can we roll to the second problem? Now, this problem, OMG, this is great, because what we have is we have a variable on both sides. That's amazing. Okay, something different for us to tackle. When we have a variable on both sides, let's concentrate on getting the variable to the left side. So I'm going to take away my diagram here, and I'm just going to take away my little symbol here, and I want to start my problem over here to the left, just in case we may run out of some room here. So what I have is 2x minus 3 is equal to x plus a negative 1. Please be aware that that's the same thing. This x plus a negative 1, that's the same thing as x minus 1. Okay, so let's not get too afraid of that, and understand that we're going to have to add 1 to both sides. But first, and very first, we need to get all the like terms on one side. So the very first like term I want to get on the same side is this x. So here, that's a positive x over here. So we would have to subtract that x here. Now remember what we said, a variable with no coefficient, that coefficient is 1. Do you guys remember that? So here, this is a negative 1x. So when we subtract negative 1 from 2, is going to give us x minus 3, and that's going to equal to, because that's 0. 1 from 1 is 0. So the x disappears, and that's a negative 1. Well, now we're down to a one-step equation, and we need to do the opposite. The opposite would be to add 3. Once we add 3, we're going to bring down our x, because that becomes 0. And here we have that same situation with a negative 1 and a positive 3 will give us a positive 2. So we was able to get it all over there. I was surprised. That's why I put that there. But anyway, let's go ahead and check it to make sure that what we have right, and we're going to put the original equation back in. So that's 2, and where we see an x, we're going to put 2. X times 2 minus 3 is equal to 2 plus a negative 1. Okay, so 2 times 2 is 4 minus 3 is equal to, and if you look at here, let's just go ahead and complete it since we had to do that multiplication. 2 plus a negative 1, and then here we're going to subtract. If we subtract a negative, that's going to give us 1, and over here a negative 1 and a positive 2 give us 1. Well, guess what? We have an identity, so that means our solution of x equals 2 is correct. Okay, last problem. Again, we have variables on both sides. That's not a problem. Remember, we're going to bring like terms together on one side of the equal sign. So we have here, I just like doing it. It's just a lot of fun to start off with solving our problems from this side. So here we have x plus a negative 5 is equal to 2x minus 1. Again, this is the same thing as x minus 5 is equal to 2x minus 1. And something else we can see. We can also see that if we want to keep this, we can do x plus a negative 5, which is consistent. You do this just to make sure that you know that you're going to be adding and adding, is equal to 2x plus a negative 1. So you see, now let's go back. Here we're going to be adding 5 or adding whichever we decide to bring. But just for the sake of fun, we took the variables to the left side prior. Let's take them over to the right side this time. It's not going to hurt us. Let's just do it. So negative x, and we're going to be subtracting, moving the variables to the right side. So of course 1x is going to be 0. That's going to give me a negative 5 is equal to x minus 1. So what I'm going to do is I'm going to add 1. I'm going to add 1. This is going to give me 4. Please do not forget the rules of integers. Is equal to, of course, x. Now we need to check to make sure that we did the right thing. So everywhere I see an x, I'm going to put 4. So 4 plus a negative 5 is equal to 2 times 4 minus 1. Oh, what did we do? What did we do? Can you see what I'm saying? I hope so. I definitely hope so. If you see what I'm seeing, you can see that this should be a negative 4. So again, that's the good part of checking this work, because we can find these differences in these signs that we do, the mistakes we do with integers. So here x should be at a negative 4. So let's start it off again. So we got a negative 4 plus a negative 5 is equal to 2 times a negative 4 minus 1. Now, signs are the same. We just add the absolute value. 5 plus 4 is 9. Keep the sign. Is equal to 2 times a negative 4 is a negative 8 minus 1. Let's rewrite this as a negative 9 is equal to a negative 8 plus a negative 1. Here a negative 9 is equal to a negative 9. Voila. Identity. Okay. Please remember one thing that I learned this summer from the University of Stanford, that math and mistakes are like brothers and brothers. We welcome them. I'll talk to you soon.